Hi everyone and welcome back to Oxford Online Maths Club. I'm joined again by some of the people who presented maths on the live stream this term in season 1. I'm joined by Flora, who talked about topology, Francesca, who talked about epidemics, Itiat, who did some Olympiad problems with us, and Deepak, who did some curve sketching with us. Say hello everyone.
Hi.
Brilliant. Okay, first question. We'll take it in turns, I guess. How did you choose what maths topic you were going to talk about on the live stream? How did you decide what, out of all of the mathematics, you wanted to talk about? Who wants to say that?
How do we decide who goes first?
Yeah, I know.
You should just
you're
pick
talking
one.
now, so Francesca.
I guess I just volunteered, didn't I? Well, for me, it was quite an easy choice, really, because the topic I talked about, which was like mathematical modeling and epidemiology, is what I'm doing my DPhil in. So it's what I spend my entire life doing and talking about. So it was quite a natural choice. And I also thought, actually, at the moment, it's extremely topical because everyone will be well aware of the idea of mathematical modeling of infectious diseases because of the COVID pandemic. So I thought actually it might be the sort of thing that people would find interesting to learn a little bit more about what's going on behind the scenes with that kind of thing.
I think it was interesting. People in chat seem to really appreciate seeing some of the mathematics behind coronavirus modelling, which has been in the news so much, of course. Who's next? Flora, you talked about topology, which is one of your courses that you're doing at the moment, isn't it?
Yeah, so kind of similar to Francesca in a way. My talk was about something which I had just been studying a lot this term. I mean, I have been doing other things too. I think I talked on the live stream about which courses I have been studying this most recent term, because I'm doing a mixture of quite pure maths and then probability and statistics as well. But for me, topology was one of the courses that I just started to really love and get interested in. And things kept coming up in the course that were like, oh, I could explain this to like lots of students and they would get bits of it, even though there was lots of kind of complicated algebra and theorems going on behind the scenes. There were some really cool results that I thought, I can tell about homeomorphisms. They would like that. It would be interesting. And as well, topology was something which kind of captured my attention when I was in year 12 myself, going to open days and stuff. Like they would do a talk about what's maths like at uni, and they would mention you can study cool stuff like this, where like a mug is a donut, and that totally captured my attention. And so I thought that it might kind of interest some people and give them something to research further, maybe.
It's a great fact. It still surprises me, the kind of mug donut comparison, even after the live stream and even after hearing it so many times before. It's still a great topology fact. Yeah. Bro. Who's next? Deepak, you did some curve sketching. Why curve sketching? What's going on with curve sketching?
To be honest, I don't feel like my answer is anywhere near as interesting as others. I just quite like graph sketching when I was in sixth form. It's quite good. Like there can be quite a lot of problems in graph sketching where they really get you to think about all sorts of functions in slightly weird ways, or the behaviors at like certain points that don't really come up in other contexts or straight up. Like they don't say, well, what happens to x sine x as x goes to 0 or whatever. But just having to draw them out, really having to think about how functions and things add up it's just quite a fun process, really. I just quite enjoyed it. So
I think that's the clip that I used for a clip of you saying something like that, of there's lots of things you've got to think about, is the clip I used in the highlight reel of your sort of insight into there's so much to think about. And Itiad, how did you choose to choose the problems that you were talking about?
Right. At first, I wanted to talk about something that I learned from the course, like in Oxford. But then I realized I didn't really want to spend an extra hour talking about my course. So, so I came up with some of the problems that I came across before uni when I did Olympiads, and I chose the problem so that they had really really neat and easy solutions, because no one wants to hear about really complex and what's the correct term? I'm not sure. Complicated solutions. Anyway, so.
All your problems had quite
technical solutions. Yeah, never mind.
Your problems had quite neat. There was a good idea in each of the problems we did.
And I chose the problem so that they had some sort of relations to the further maths. Like one of the problems were related to a monk and the monk was going up a mountain and then coming down, and we had to find a point. And it had a neat relation to the intermediate value theorem, which we learned in analysis. And then there was a problem with an ant, a bunch of ants, and we had to find an invariant, which is really important in a lot of physics and maths. So yeah.
Cool. Yeah, so links to other bits of maths. So it might have started as sort of super curricular mathematics, sort of outside of the curriculum that you're doing at Oxford or in school before, but then weirdly has these links back to stuff that you do at university.
Yeah.
That's quite nice. Lots of people in the chat have been asking about how you find extra bits of mathematics, or how you find other things to be interested in outside of school maths. I think people know that it's important to be interested beyond the classroom if you're writing a personal statement or preparing for university mathematics. I was wondering if anyone had any advice on finding extra bits and pieces of mathematics.
In my live stream, I recommended some books, Flatland and Flatterland, just going to plug them again. And I think it's really good that they're okay. Flatland is a specific kind of topic. Flatterland covers a few more different things, and I think if you can read, there's some good books by I think Ian Stewart and someone else that cover like a range of different maths topics. And if you read a chapter of something that you find interesting, then get another book that's like more in depth on that topic. Or to be honest, you can do a lot of like research on Wikipedia. Like if you just search, like a lot of it will be too difficult to understand maybe, but a topic that seems interesting, and then you can kind of look for other resources on that topic. But yeah, there's lots of good further resources on the Oxford Online Maths Club website. So find something that you're interested in and kind of go from there, and you will see how it links to other things.
Deepak, did you want to add to that on finding maths?
I don't know. Back in the day, I used to quite like doing a lot of STEP. And while that's not great for sort of finding topics and stuff, a lot of the questions, when you don't really have the pressure of the exams, because the way a lot of STEP questions are structured is like part A will sort of introduce you to some idea, right? And then part B will sort of be like, oh, just use that idea to solve a similar problem or something. But sometimes a lot of them ideas or things just come up in places you don't expect them things. And a lot of the questions themselves are like, a lot of the questions I find when I tell people are like interested in maths, I'm like, oh, look at this and stuff. They'll be from things like STEP. Like at the end of our live stream, when I talk about the devil's curve, that's from a crazy STEP question and stuff. But I don't know. I don't know. I think I'm just weird, and I used to quite like STEP because I feel like when you don't have the pressure of the exam, you can appreciate it a bit more. But I don't know. That kept me going for a bit.
Definitely trying questions without time pressure. I think lots of the viewers would like to try some STEP questions because there's lots just out there on the internet, isn't there?
Yeah,
I think one of the problems in the last MAT exam was on elliptic curves. I'm not sure exactly. Yeah, that was fun.
That was good.
Matt 2020 has a question that's sort of slightly on elliptic curves.
Wait, was that question? I think that was the question I was marking.
Oh, do you remember marking? It had a cubic.
I remember there was something that looked like a fish, so that's probably an elliptic curve.
That was an elliptic curve. The question didn't really get you to do anything elliptic curve-ish, really.
Mm-hmm.
For good reason.
But it did secretly have an elliptic curve in it.
Another thing I just thought was when I was in sixth form, I think I joined the IMA, which is the Institute of Mathematics and its Applications, which is like a professional mathematics organization. But they do a lot of talks on all sorts of things. And I'm not sure if necessarily all of them would be at an appropriate level for someone in sixth form. I think they vary a little bit depending on who's giving the talk and what the topic is. But in general, they are not too technical because they're aimed at sort of a broader audience. So mathematicians who aren't in that field, so they don't go, too much in depth into a particular area. So they're quite accessible. So that's another sort of way that you can find out about some interesting maths is kind of sign up to them, and they send all these emails to you about talks that are happening on all sorts of different things. There was a really cool one that I wanted to go to recently, but I couldn't, which was on forensic statistics, which I thought sounded really, really cool. And it was about when they found the body of Richard III in the car park back in whenever that was, several years ago now. And there was a question of how did they actually identify that it was Richard III and not some other person. And there was apparently a lot of maths involved in doing that. And I was like, I had no idea that maths would be used with something like that, but it was.
Something I liked about the live stream was the audience interaction we had through the Slido chat. I don't know if any of you were helping answer questions in the Slido chat at any point, or if you could just see what was going on. I wondered if there was anything you saw happening in the audience participation that you particularly liked, or anything you remember. I had a quick look while you're trying to remember something memorable from chat. I had a quick look. The kind of things with the most thumbs ups, with the most likes, were entirely memes. So it was entirely people asking for likes, or people impersonating celebrities. There were at least 3 different people pretending to be Grant Sanderson. I can tell from login records. Other math celebrities also in there. But way further down, a thing I liked to get the ball rolling was way further down. I saw an anonymous person ask what's induction, because somebody had mentioned mathematical induction in passing. And then I saw a different student watching, not one of us, answered their question. They explained what induction was. And there was a sort of to and fro of this anonymous person and Molly, one of the people who watches, just talking about maths in the chat, which is something I liked a lot, seeing that kind of interaction. Does anybody remember anything else that happened in chat?
It's funny because the first thing that came to mind for me was basically what you said. Like, sometimes when I was modding the chat, there was a total influx of questions, and I would try and get through them all, make sure each one of them had been answered by someone. But often it was like even anonymous people having conversations with each other, but like properly explaining maths. And it was really nice to see them interact with each other, because it helped me get to more questions that hadn't been answered. And yeah, that sense of community and people helping each other. But I like it when people ask us questions. Like when you're modding the chat, you feel a bit like anonymous because you're not on the live stream, but people still ask you like, what do you think about this topic? What's your favorite area of maths? And it's really nice to have that engagement.
I remember getting some really, really intelligent questions, which was really nice to see. And it was quite sad, actually, that I didn't really have time to actually answer all of them. But a lot of people were coming out with sort of really insightful things, like, as I was talking about, sort of a very simple model just to illustrate the basic principles I was talking about. And a lot of them were coming out with things like, but what if the disease does this? Or what if we're in this situation? And how can we extend it to do this? And all that kind of thing. I mean, I struggle to remember specific questions, but I do remember generally there were a lot of really, really good questions coming out.
Yeah, I think people are really good. And that's something about having the interaction all the way through, means that rather than taking questions at the end or even on a break in the middle, we were getting questions about stuff all the way through. And somehow, if people didn't understand, they would say straight away. And I usually don't get that in a maths talk. That usually
the question I remember the most came from you, James, which was when I was running those simulations. I did 10 examples of running that simulation to look at what was happening on average. And I was saying that on average, it was 50% of the time you'd see a large epidemic. And you were like, well, but there's 6 out of 10 here, not 5 out of 10. You were like grilling me on like what the probability of like that happening.
I believe you settled it. I believe you said, I'm the expert. It's fine. That was cheeky of me. I was trying to I didn't brief you on it, but I was trying to do a link back to, I think possibly the previous episode had been on hypothesis testing and what happens when a binomial gives you something other than the average. Is that suspicious or not? So I could have warned you that was maybe a link back. Yeah, I really grilled you on the 6 versus 5, sorry.
I was just sat there like, James, stop it.
Is there any maths that you wanted to talk about on the live stream but we didn't have time for, or stuff that you've thought of since we did the live stream? Who wants to go first on this one?
Yeah, so actually, surprisingly enough, so we didn't get to do it in our episode, but you did sketch it in the episode after mine. So what the graph was, it looked a little bit like a bell curve, but it was slightly asymmetrical. And what it was secretly in disguise was actually an example of the Maxwell-Boltzmann distribution, but I'd messed the constants around, so it was a bit easier to sketch. And what that really is, it's a probability distribution. So what it essentially tells you is the chances of finding particles in certain conditions at certain speeds. So if you imagine having a bunch of particles in a box, right? Since all the particles are sort of moving around, bumping into each other, sometimes they'll sort of bump and sort of be aligned in a way that increases their velocity, and sometimes they'll sort of like cancel out, right? So there's a sort of a range of speeds of the particles inside of this box. And the idea is that, well, even if you have a box at room temperature, there's still a chance you might find the particles be moving quite fast just by pure chance, or maybe it's barely moving at all, right? And what this probability distribution does is, given some initial conditions or some conditions of the box, as per se, the main one of interest being temperature, it tells you the chances of finding certain particles at certain temperatures. You sort of like find the area between the two temperatures you want, and it gives you the probability. And if we'd gone on to sketch that, I would have added in the other variable t, and you would have seen if you increase the temperature, the distribution sort of shifts like that to further on, so you're more likely to find things at a higher temperature. And it's useful for all sorts of things. Like it's quite good at explaining things like evaporation and stuff. But you'll see a lot of things like in maths when they're modeling fairly like random processes where they're trying to get like useful deduction out of it, is a very big field called stochastic something. And you see things like random models, things like that, quite a bit actually. One fairly famous example, or I might just be waffling now, is one of Einstein's very famous papers on so before Einstein, they noticed when you had pollen in like a beaker of water and you zoomed in on it in a microscope, all these particles would just be flying everywhere. And what Einstein basically showed is it's a consequence of the water molecules sort of moving around in that. So it's bumping into the pollen, which would give it slightly, because in the beginning, the guy just assumed the pollen was literally alive, right? It was moving, sort of swimming, right? But Einstein basically showed, this is one of his 4 papers in his so-called miracle year. He basically showed that it can be explained, the fairly erratic behavior, from the random motion of sort of atoms or particles in water. And why that was so groundbreaking was that was the first sort of solid evidence for particles to exist, sort of like actual particles being there, little things that are moving around and knocking into each other. That was the first sort of thing. So yeah, modeling random stuff is very useful, basically.
Amazing. Physics.
Brownian motion is the name.
That's
for
the
it.
one.
I know this because this is what I wrote my 4th year dissertation on. Molecular dynamics simulations of liquid water and how they interact with other particles. So yeah, that is another field of maths that I would probably not give a presentation on because I did that a long time ago. But yeah, it's very interesting.
I guess wrapping up, is there anything else that you want to tell people who have been watching the Maths Club live streams, have been following along the further reading?
I want to thank them for their support.
Yeah.
So, being cheesy like that. But yeah, I think stay strong, because some people will think that you're weird or nerdy for being obsessed with maths, but I think it's really cool.
Thank you, Flora.
Yeah, just like believe in yourself,
I know you were saying that to them, not me, but I felt it.
For all of you as well.
I guess I wanted to say that you were talking about how like you could do further maths like, after curricular maths, and for me it was quite the opposite, because I was interested in maths, like in curricular maths, because of Olympiad maths, and some of the ideas in Olympiad maths were really cool, were cooler than the curricular maths that I was doing at the moment. So that was kind of an indication of how maths could be really nice. So if you're not particularly finding your curricular maths really nice, you could like try other stuff, and that could motivate you to do curricular maths, because maths in the end is really cool. Sometimes you don't see it in your textbooks, but it is cool. So yeah.
Yeah, it's a good point to remember that there's so much more to maths than what you see at school.
Yeah, maths is a lot bigger than just A-level maths and further maths. And I think a lot of people that study maths at school think, this is okay, but, what's the point of it? And I think once you get to university and you start studying it in more depth, you realize how broad a field it is and how many different bits of maths there are. And we're kind of evidence of that, because we're all doing completely different things. I mean, like I personally didn't even realize mathematical epidemiology existed until I was in third year of my degree. So there's so much maths out there that you just don't even know exists. So, I think it's worth exploring and finding out as much as you can about it. So yeah, I don't think anyone really knows when they're in sixth form exactly what field they're going to end up in. Definitely not. It's just something you find as you go along, and you figure out what you enjoy and you just follow that. And I think if you do that, you end up in the right place for you, hopefully.
Thank you everyone for joining me again, and thanks for being on the live stream this term in your separate episodes. It's been really great to chat to you again, and best of luck to you next term if you've got exams next term. Otherwise, have a nice term, and we'll see you around. Bye.
Thank you.